We've seen how to make predictions with our machine learning models once it's learned some patterns from the data, aka using those patterns. Now, how do we figure out whether those predictions are valid? Such as, could we use them in production? Or is our model just making things up? Or those predictions, do they actually hold water? So this is what we're going to cover in this section, is step 4, evaluating a model. So we'll get rid of this, but we'll put in a little heading here, evaluating machine learning model. Beautiful. Now, the first place we're going to have a look at is up here. And this is a Scikit-learn documentation. We can actually find this by going Scikit-learn evaluate a model. And it should come up 3.3, metrics and scoring. That's what we're after. So as you can see here, there are 3 different APIs for evaluating the quality of a model's prediction. And we're going to have a look at each of these. So we've got an estimator score method, we've got the scoring parameter, and we've got metric functions. You could read through this, but I prefer, as you probably do prefer too, is getting hands-on with the code. So let's see it in action. All right. Now, to do so, we're going to bring back our heart disease classification problem. We could scroll up and copy it, but again, I want you to get some practice writing it out, right? Because this is what we're here for. We're here to practice writing machine learning code. So we're going to import, this is a markdown cell, so I'm going to change that to code. We're going to import the random forest classifier. We've seen this before. And then we're going to set up a random seed. Wonderful. And then we're going to create our X and Y, our feature variables, heart disease.drop. We've already imported the data frame heart disease and axis equals 1. Beautiful. And we'll create our labels, heart disease. This is target. Excellent. Then we'll split it into train and test. So X test, Y train, Y test equals train test split, X, Y, test size equals 0.2. Wonderful. Then we'll instantiate our random forest classifier. Random forest, we could probably press tab here. We certainly can. And then we're going to fit it. That wasn't too hard, right? By now we're becoming experts at writing this little section of code, and being realistic here, that's a full-blown machine learning pipeline right there. Right, as long as the data's in the right format and we've got the target column, we can do this pretty quickly. So now, if we run this, we can see that our model fits itself to the data. So basically it's finding the patterns in X train and Y train, or between those two. And so now we can use the scoring parameter. What we might do actually is copy this. We go 3 ways to evaluate Scikit-learn models / estimators. Now this is just from the documentation. So we want 1 is estimator score method. This is the one we'll have a look at first. And then 2 is the scoring parameter. Scoring parameter, we'll have a look at that shortly. And then 3 is problem specific metric functions. Beautiful. So now we've got a little heading, we know what we're working with. So the first things first, we're going to check out the score method. So maybe put another heading in here. 1, 2, 3, 4.1, evaluating a model with the score method. Now, we've already seen this one, right? Because this is basically the default. It's a way to get a quick sniff, a quick understanding of how a model's doing. So if we call clf.score, right, because that's the score method, every estimator in Scikit-learn has this little score method. So once you've instantiated a machine learning model here and you fit it to some sort of data, you can get its score. So look, we could even get its score on the training data. How does it go on here? 1. So it fits the training data perfectly. And then if we go here, score on the test data, 85%. So we've seen these figures before, right? Now, what is happening here? Well, let's have a look. Let's press Shift Tab. Remember, you can press Shift Tab within any method to see what it does or see its docstring. Returns the mean accuracy on the given test data and labels. And so what's happening here is that a model that would predict perfectly would get 100% here. And actually, I would say you should be skeptical of any model that gets always 100% because no model is perfect, right? If your machine learning model is always getting its predictions right, I'd say there's some sort of error in your data or some sort of error in the way you've trained it. So our model doesn't get everything correct, but at 85%, it's still far better than just guessing, right? Because remember, we've got two labels, heart disease or not. And so guessing would be just getting about 50%. Now, let's do the same as above, except with some regression code. And this time, I'll let you off for this video. We've already typed out a little machine learning pipeline. We'll come up here and we'll copy our regression code. We know it's regression because we've got the random forest regressor. And so we'll write in a little comment here. Let's do the same, but for regression. Beautiful. What we might do is just fit it. Oh, we've already got the fit function there. See? Confusing myself. Beautiful. So the model is now fit, and now we'll do the score. Because we've run this cell, our X-test data has been replaced with the Boston data frame rather than the heart disease. So now we can just call it on X-test and then Y-test. Wonderful. And so you might be thinking, well, these numbers are quite similar here. 0.85, 0.87, and you're right, they are pretty close. But in fact, our regression model is actually, when we call score, it's actually using a different metric. Returns the coefficient of determination, or R squared of the prediction. Now, we'll dive a little bit deeper into some specific metrics per problem, but the thing to remember here is that the score function on every machine learning model has some kind of default evaluation metric built into it. So if we call the random forest regressor, chances are it'll use the coefficient of determination as the default score metric. And now if we call any regressor, if we go back to our machine learning map, if we call any one of these estimators here in the green boxes, the default metric will likely be the coefficient of determination because they will all be regression models. And the same goes for classification here, right? Returns the mean accuracy on the given test data and labels. So for all of these classification models in the green squares here, the default evaluation metric is accuracy. And so what happens when the score method gets called? The model makes predictions on X test, creates Y predictions like we've seen up here before, Y preds, and then it compares those predictions to the test, to the actual labels, and then returns back some sort of metric to compare how well our model actually did. All right, that's the score parameter in a nutshell. Makes some predictions, compares them to the actual real labels, and then gives us an idea of how well our model's doing. So this is probably the first one that you'll call when you first train and fit a model. You'll call the score parameter. That's why it's listed as the first one here in 3.3, the Scikit-learn documentation for metrics and scoring. So now we've seen score. Let's check out the scoring parameter. So what we'll do here, we'll create another heading ready for the next video. 4.2, evaluating a model using the scoring parameter. So before we get into that one, I would say press Shift Tab here and have a read of the doc string here and see if you can figure out what the coefficient of determination is. And the same thing goes for the accuracy here, or the classification default score metric. Press Shift Tab and have a read through here and see if you can understand what's going on. If the doc string doesn't really help you, try check out the documentation here, model evaluation. But otherwise, I'll see you in the next video.